Let's open that question. December 2017, question 2B. December 2017, question 2B. Just let me take you through just a recap on how we're doing the hypothesis testing. There are some steps followed in hypothesis testing. One, you determine the null hypothesis, alternate hypothesis. Then you determine the significance level. And then from there, you compute either Z or T statistics. Say that Z statistics is applied for big proportions, that is 30 and above. But for T, it's applied when N, population size, is less than 30. Good. So in December 2017, question 2B, you are told that a company produces two types of electric components whose information has been provided to you as follows. We have component X, component Y, then mean life in hours, that's the average, that's the X bar, standard deviation in hours, and then the sample size. So in this case, the sample size is more than 30, therefore use a Z test. Determine whether the quality of the two types of electric component differs significantly. So in this case, we have a two sample mean. We said our null hypothesis will be mean of 1 is the same as mean of 2, and the alternate hypothesis that mean of 1 is not equal to mean of 2. Then significance level, you are told to use what? 95. So that means the level of significance will be 5%. And then from there, since you're having a two sample, we use Z. In case we have a two sample mean, you take X bar 1 minus X bar 2, you divide by standard deviation of 1 square over N of 1, plus standard deviation of 2 squared over N of 2. Then you get the square root. So the mean of the first sample for component X was 1600. You raise the mean of 2, which is 1528. Then you divide by the square root of standard deviation of 1 is, we have 130, 2 square over N, its sample size is 120, and then you add 149 square over its N, which is 110. And what do you get? You get 3.87. Then that's being our Z calculated, we compare it against Z statistics. So we say that if a null hypothesis, the equality is not equal to, we use a two-tailed test. We say that in case of a two-tailed test, in this case, we'll have alpha over 2. So our level of significance is 5%. So 5% divided by 2, it will be 2.5%, 2.5%. If your Z calculator is with that, that means you accept null hypothesis. If this, that means you reject null hypothesis. Also, when it's on this side, you need to reject. So let's get that. Using the Z statistics, 5%. Is it 1.96? Yes, it's 1.96, positive, negative. Or we say that if I take you back to the normal distribution is classified into two, half. So just take 0.5. I'm taking that proportion, 0.5. And then we have this probability of rejecting, which is 2.5. You deduct 0.025 and you have 0.475. And then since you have this probability, and you want this probability of accepting, that's 0.475. You read this one inside the table, and we're using the Z distribution table. If you read 0.475 inside the table, you'll get a coordinates within the coordinates of 1.96. So now let's comment. Now in this case, you are comparing your Z calculated, which was 3.87, Does it fall in between the acceptance region or rejection region? Remember, this is positive 1.96, negative 1.96. 3.87, it's above 1.96. That means we do what? You reject null hypothesis at 5% significance level. What does it mean? If you reject the null hypothesis, you accept the alternate hypothesis. And the assumption is that mean of 1 is not equal to mean of 2. That's the truth, because 16 is not equal to what? 1528. Good. Take a screenshot of that. I'll try another question. November 2016, question 1C. November 2016, question 1C. So we are told that the data below Let's try another question. Can try the last question. Yeah, November 2015, question 5C. November 2015, question 5C. So you are told that the sales manager of USA Limited has obtained the following data on the values of a random sample of 100 outstanding sales invoices of the company. So our sample size in this case, we have 100. So that means in case we are to carry out the hypothesis testing, we'll be using a Z-test. So you are given the values, but in this case, you are given in terms of frequencies, then the number of outstanding sales invoices. Required, the standard deviation of the random sample, standard deviation. So in this case, we have the value, let your value be X. And how do you get your X? So whenever you're given in frequencies, for example, the first one is between 0 and 100. So you take 0 plus 100, then you divide by 2. And you'll get 50. The other one, you take 100 plus 200, then you divide by 2, and you get 50. 200 plus 300, you get 500. You divide by 2, you get 250. The other one will be 350, 450, 550, 650, 750, and then we have 850. Then you have the probabilities. So you are given the number of outstanding sales invoices. So what you're supposed to do, you're supposed to add the total of which we know the total is 100. So for example, the first probability will take 20, you divide by the total 100. So you'll take 20 divided by 100. The second one will take 18 over 100. That's how you get the probability. So it's 0.2, 0.18, 0.22, 0.15, 0.09, 0.08, 0.4, 0.2, 0. So you have X, you have probability. So first of all, you need to get the average X bar, and X bar, you just take X, you multiply by the probability, and then we need now to get the standard deviation. So to get standard deviation, you take X minus X bar square probability, you add, then you get the square root. So let's do that. The first one, you take 50 times 0.2, you'll have is 10. And then you add the total. You're getting 287. So that's how you get the mean whenever you have the probabilities. Then let's get the standard deviation. You take your X, and X we had was 50, 150, 250, 350, 450. Then you deduct X bar, and our X bar was 287. Then you multiply by the probability. So once you get the total of the standard deviation, then that's when you get the standard deviation or the square root. And you have a standard deviation of 198.32. Then number two, let's go to number two. Number two, later. Number two, a 95% confidence level of the mean value outstanding of the sales invoices. So number two, it's all about the confidence level or the confidence interval. So the confidence level of the mean value outstanding of the sales invoices. So just take X bar plus or minus Z standard deviation square root of N. And our mean was 287 plus or minus. Then we get what we call the margin of error. Z, if you're using a two-tailed test, in this case, we're taking a 95% confidence level. So that means the significance level is 5%. And then we say that for the confidence interval, we always use a two-tailed test. And the 5% for two-tailed test, our Z is always 1.96. You multiply by the standard deviation. Our standard deviation was 198.32. Then you divide by the square root of N. And our N was 100. So you have 287 plus or minus. So you need to get the margin of error. Of which is that 8.87. So that means can increase. You may have 325.87 to 87 minus that 8.87, and you have 248.13. So our confidence interval, confidence level, that means our X bar will lie in between 248.13 and 325.87. Can take a screenshot of that. What we have done is X minus X bar square probability. Then you add all of them. You add all of them to get a sum. Yeah, it's not this. There's a difference between it. If X minus X bar square probability, then you get the square root, then you get summation outside the square. Sorry? Yeah, it's X bar, that's the mean. This is the summation. Yes, the summation. Your summation, it's like taking the total divided by the 100. And this is the kind of probability. No. Don't work like that. It's not X minus that X bar. For example, I pass in 10 and 7. X bar is over. X bar like that. Now let's do some question now on game theory. So let's start with the last sitting question. Yeah, November 2020. November 2020, question 1B. So you're told that a game between two players, A and B, has the following pair of matrix. So we have player A strategies and we have player B strategies. Required the optimum strategy for each players. So you have two players here. So we have player A, then we have player B, So B has 4 strategies, B1, B2, B3, B4. And player A also has 5 strategies. Strategy A1, A2, A3, A4, A5. Hope you recall on the steps we follow on the procedure of solving a game question. 0. We have 2, 1, 11, -1. So one of the steps, we say that player B adopts the rule we call max-min rule, but player B adopts minimax rule. So the first step, we say that you start, then from there, you have the payoff table, then from there you test whether there is a saddle point. And how do you test there is a saddle point? So if player B is applying max-min, that's the maximum of the minimum, you take the minimum, and here the minimum we have is -4. The minimum we have is also -4. The minimum we have is 3, and the minimum we have is -7. And then you choose the maximum. So it's the maximum of the minimum. So you take the maximum, and the maximum you have is what? It's 3. Then player A applies minimax. So minimum of the maximum. So determine the maximum for each strategy of player A. And the maximum here we have is, we have 13, we have 8, we have 3, we have 11, and here you have 9. Then you choose the minimum, and the minimum you have is what? 3. Do you have a saddle point? Yes, there is a saddle point, because here we have a 3, we have 3. So the gain of one is exactly the same as the loss of the other partner. So that means our game is optimal. So the optimum strategy for each player. So if you want to get the optimum strategy, so we have for player A and we have for player B. So player A will adopt strategy A3. When you apply strategy A3, player B, where you have this, will adopt strategy B3. Good. That's the optimum strategies. Then number 2. Number 2 is the saddle point. And the saddle point in this case, we have for A, it's A3, and B, it's B3 with a saddle point of 3. And that 3 becomes the value of the game. Whenever there is a saddle point, you have 3, we have 3, that becomes the value of the game. So the saddle point is the meeting point between strategy A3 and B4. So now let's be here. We're looking at the saddle point. So the saddle point is why we have B3 and A3 meeting, and we have what? 3. That's why I'm getting these 3. And then what we have here as the maximum, and this minimum becomes the value of the game. The value of the game. So to get the value of the game, you don't take this, but you take what you have here. So that one becomes the value of the game. And number 3, that was the question. The value of the game. Good. And take a screenshot of that. So you can do another question. December 2017. December 2017, question 4B. December 2017, question 4B. After class. December 2017, question 4B. So you're told that two airlines, K and Q, are interested in increasing their market share. Airline K has three available strategies: advertising its special fare, advertising its unique features, or advertise its safety records. On the other hand, Airline Q also has three available strategies: do nothing, advertise its special fare, or advertise its special features. So we have two players here, each with various strategies. The matrix below shows the gains and losses associated with the different available strategies in millions of shillings. Positive value favors Airline K and negative values favors Airline Q. So you have that way of matrix where you're given those strategy K1, K2, Q1, Q2, Q3 required. The optimal strategies for each airline, and then you compute the value of the game. So we need to follow the steps. And step number one, first of all, you have to determine whether there is a saddle point. So here we have Q1, Q2, Q3, K1, K2, K3. So this is Airline K, Airline Q. Then you have the P of matrix. We have its negative 30, 0, negative 90, negative 40, negative 15, negative 20, 80, 20, negative 50. So we are saying that this player adopt the max-min, and this player adopt the min-max. So you determine the minimum from player K, and the minimum you have here is 90. Here you have is negative 40, and the minimum here you have is negative 50. Then you choose the maximum, and the maximum we have is, the maximum we have is negative 40. We do the same for player Q, but for player Q adopts the strategy of minimax. So you take the maximum, and the maximum here you have is 80. Here you have 20, and here you have negative 20. Then you choose the minimum. Is the minimum of the maximum. The minimum is negative 20. Is there a saddle point? No, so there is no saddle point. So if there is no saddle point, you ask yourself a question: is it a 2x2 matrix? It's not a 2x2 matrix. If it's not a 2x2 matrix, that's when you apply dominance rule. So apply dominance rule to get a 2x2 matrix. And we say that dominance is all about avoidance of some strategies. That means some strategies will be dominated by other strategies. So Q1, Q2, Q3, K1, K2, K3. So how do we apply dominance? So if I take you back to the rules of dominance, we say that you take the maximum from the first row. And the maximum you have is what? The maximum you have is 0. So once you have 0, Once we have 0, can you stop writing? Come attack. So we are saying that from the first row, you take the maximum, and the maximum you have is what? It's 0. Then you apply across that column. So that means 0 is the maximum from the first row. That means 0 is greater than negative 30. 0 is also greater than negative 19. Negative 15, is it greater than negative 20? Yes. Negative 15, is it greater than negative 40? Yes, it has passed the test. Then lastly, 20, is 20 greater than 80? No, but is 20 greater than negative 50? Yes. So that means here, in this case, Q3 has passed the test. That means 0 is greater than negative 90. Negative 15 is greater than negative 20. 20 is greater than negative 15. So that means Q2 will be dominated by Q3. So you dominate that. So that means ARN Q will sacrifice strategy Q2. So in this case, we only go with Q1 and strategy Q1 and strategy Q3. Now, let's go to K2. K2 has 3 strategies. It has to be a 2-by-2 game. So that means we'll have to sacrifice 1 strategy. So in that case, we say that you take the minimum from the first column. Let me repeat again. You take the maximum from the first row, but you take the minimum across the first column. So in this case, the minimum we have is what? The minimum we have is? The minimum we have is negative 40. Then you apply across the row. So that means negative 40 is less than negative 30. Negative 40 is less than 80. Then you apply across that row. So in this case, that one has been dominated. So don't consider that. So consider this now. Is negative 20 less than negative 90? Is it a yes or no? No. Good. Is negative 20 less than negative 50? No. So that one has failed the test. So that means Q cannot sacrifice Q2 because negative 40 yes is less than 30, is less than 80, but negative 2 is not less than 90, is not less than 50. So he cannot forego that strategy. So in case that fails the test, you still go to the, because already with Q we have the strategies, but K we don't have the strategy. So in this case, what you'll do, since K2 has failed the test, you go to the next minimum. And the next minimum from the first column is how much? We have negative 30. So that means negative 30 is less than 80. So you don't look at this. So in this case, you don't focus on Q2 because it has failed the test. That means negative 30 is less than 80. You apply across the row. That row. Is negative 90 less than 50? Negative 50? Yes. So that means negative 30 is less than 80. Negative 90 is less than 50 and negative 50. So that means you cancel which strategy? Is it K1 or K3? Good, you cancel K1. So with that now has reduced to a 2-by-2. Has it reduced to a 2-by-2? Yes. So that means we have 2 prayers here. We have prayer Q. Q will adopt strategy Q1 and strategy Q3. K, we have cancelled that. So we'll focus on strategy K2 and K3. And what are those payoffs? So here you have negative 40, we have 80, then we have negative 20, negative 50. Good. So then from there, how do we solve that to get the value of the game? Since it's a 2-by-2 matrix, so let me take you back to the steps. We say that number 1, you start, you develop the payoff table. That's what you have done. Then from there, we test for saddle point. In this case, we didn't have any saddle point. In case there is no saddle point, you ask yourself, is it a 2x2 matrix? So in this case, it was not a 2x2 matrix. So thereby, you apply the dominance. So the motive of the using dominance is to make the strategies reduce to a 2x2 game. When it's reduced to a 2x2 game, that's when now you apply algebraic method. So let's solve that. So we had -40, -20, 80 negative. And how do you apply the algebraic method? We said you get the range. You get the range. So in this case, it's -40. What's the difference between -40 and -20? The difference is 20. What's the difference between 80 and -50? The difference is 130, not 30. In this case, it's 80 against -150. So it's not 80 and 50, it's 80 and -50. Then we get the range across. What's the difference between 80 and -40? 120, good. What's the difference between -20 and -50? The difference is 30. Once you get the range, then you interchange. So this 30 goes there, this 120 goes there, same here, 130, and here you have 20, so interchange. Then from there you get the probability. And how to get the probability? You take 130 plus 120, you get 150. So in this case, you'll be taking 130 divided by 150, 20 divided by 150. So what do you get here? 0.87. Therefore, this will be 0.13, right? Then the same here, you get the probability. You take 30 plus 120, of which the total is 150. So we'll be taking 30 divided by 150, 120 divided by 150. 0.2, this one will be 0.8. So now let's get the value of the game. And to get the value of the game, we say that you take the payoffs. So you take -40 with its joint probability, both across the row and the column. So the probability you have is 0.87, and then you multiply by its probability across the column of 0.2. Then you add the other payoff was -20. You multiply by probability of 0.87. You multiply by its probability of 0.8. Take the other payoff, which is 80. You multiply by the probability of 0.13. Multiply by probability of 0.2. And lastly, -50. You multiply the probability of 0.13, 0.8. Good. So you can take a screenshot. And kindly remember to familiarize yourself with game theory. That's on the theory part. What are the rule of dominance, the limitations, assumptions of game theory, classification of game theories? Those are highly examinable area, and you have them in your handout. Have them in your handout. So you can try the last question on game theory. December 2011. December 2011. December 2011. Question 3B. December 2011, question 3B. It's on page 6. So you're told that Nico Limited and Tini Limited manufactures and sells sports uniform in Tinico region. The two firm controls the entire market in the region. If both firm makes the same type of the change in the uniform during the same year, their respective market share remains constant. Likewise, if neither firm makes changes, then their market share remains constant. The payoff matrix in terms of the increased and decreased market share and a different market condition is given below. So what do we call that type of game? Where if you make a change, you either gain the same or lose the same. You make no or it remains to be constant. So required the value of the game. Number one, they need the value of the game. Then number two, outline for limitation of game theory. First of all, let's start with the limitation of game theory. So we said, what are the limitations of game theory? Or in short, what were the assumptions of game theory? One of the assumptions is that the players or the number of players is known. That's what we said, with certainty, that the number of players is known in certainty. So how can you convert that assumption into a limitation? Is that always the case? Not always the case. So in short, the limitation is the same as the assumption. You just convert those assumptions into limitation. So now let's get the value of the game. We said once you have the payoff table, you test for the saddle point. Here you take the minimum, here you take the maximum. So the minimum you have is what? -20, here you have 0, here you have 0, and then you take the maximum. And the maximum is 0. You can take any 0. Which 0 is greater than the other? The last one is greater than the other. So let's go to Tini. Tini, we take the maximum, and here the maximum we have is what? 16. Here we have is 2. Here we have the maximum is 5. Then you take the minimum. The minimum is 2. And here the maximum was 0. You can take any 0. So do you have a saddle point? No, we don't have a saddle point. If we don't have any saddle point, that's when we apply the rule of dominance to make it reduce to a 2-by-2 game. So applying dominance. So how do we apply dominance? So 0, -8, -20, 6, 0, 5, 16, 2, 0. This is Nico. This is Tini. And we have these strategies when there is no change, minor change, and when there is a major change. Same here. When there is no change, minor change, or the major change. So from the first row, you take what? The maximum. And the maximum you have is 0. So that means 0 is greater than -8 is greater than -20. Then you apply across the column. Is 6 greater than 0? Is 6 greater than 5? Yes. Is 16 greater than 2? Is 16 greater than 0? Yes. So that one has passed the test. Can you scrap that strategy of doing that? Nothing. And you focus on either making the major change, minor change, or the major change. Now let's go to Nico. Already we have found the strategies that team will adopt. Minor changes or major changes. What about Nico? He said that for this strategy, you take the minimum across the first column, but in this first column has been scrapped. So in this case, our first column will be where we have the minor changes here. Are you together? So in this column, you take the minimum, and the minimum you have is what? Yeah, here the minimum you have is -8. That means -8 is less than 0, is less than is less than 2. What about this? Is -20 less than 5? Automatically it has passed the test. -20 is also less than 0. So that means -8 is less than 0, is less than 2. -20 is less than 5, it is less than 0. So that means, which one do we cancel? Which one do we cancel? So, and from that, you have changed to a 2 by 2 game. So we'll have 0, 5, 2, 0 has reduced to a 2 by 2. So that means both of them, it's either you do the minor changes or you do the major changes, minor changes, major changes, but there is no option of doing nothing. So once we have a 2 by 2, therefore you can be able to get the value of the game. And how do we get the value of the game? You apply the algebraic method. First of all, you get the range. That's the difference. 5 and 0, the difference is 5. 2 and 0, the difference is 2. We do the same here. The difference is 2 here. The difference is 5. Then you do what? You interchange. 5, 2. Here we'll be having 2, 5. And then we get the probability. 2 plus 5, you get 7. So this one will be 2 divided by 7, 5 divided by 7. 2 divided by 7 is how much? 0.29. So that means here we have 0.661. Same here, you get the probability. 5 plus 2, you get 7. So it will be 5 divided by 7, 2 divided by 7. Here you have 0.61, 0. Sorry, yeah, it should be 7, not 61. So now to get the value of the game, you'll be taking 0 times its joint probability, 0.29, 0.71, 5 times 0.29 times 0.29. Then we have 2. Probability of that happening 0.71 times 0.71. Then you add 0. Probability of 0.71 times 0.29. Can take a screenshot of that. So on the same sitting, let's do the same part A. That question, part A. Part A of the question, it's an assignment model. So I think now you're somewhere with the game theories. And kind of go through game theory. The theory part, measure it. Know those assumptions, characteristics, limitations, and types of the game, and rules of dominance. And what do we mean by payoff? December 2011. Question 3A. So part A, you are told that Top Rank Institute of Professionals specializes in the training of accountancy and management courses. The institute intends to hold special seminar on 4 topics, namely decision theory, inventory controls, network analysis, and simulation analysis. So those are the 4 topics. The seminar are to be held once per week in the afternoon, and only one topic can be covered during any one seminar. The training manager indicates that the number of students who cannot attend in a particular seminar specific day is as follows. So you have the days of the week, and we have the topics. So in this case, we say that both transport and assignment are formulated to deal with the cases of minimization. So in this case, what are we analyzing? In short, you are given the payoff there. So what does that payoff represent? If you're not able to interpret that, so what are we given? Yeah. What are we given? Sema msome swali tena, mshaelewa Kenya tuna analyze hapo. Kuna topics na kuna days of the week. So we are told that the training manager indicates the number of students who cannot attend. Are you together? So we are given the number of students we expect to be absent when we'll be covering that specific topic. So what's the objective in this case? Is it to maximize on the number, to discourage them not to come, or is it to minimize? It's to minimize. Are you together? Yeah, you don't like the student to miss that particular topic. So these are case of minimization because we're given the number of students we expect them to miss. Good. Required the optimal schedule of the seminars. Number 1, before we solve the topics, we have 4. How many days of the week? 5. Is it balanced? It's not balanced. If it's not balanced, we say that we balance it by adding a dummy. Are we together? So in this case, we'll add a dummy what? Is it a dummy day or a dummy topic? Good, a dummy topic. So we develop what we call the first table. This one is a case of minimization, so it's okay. We don't have to modify it. So here we have decision theory, inventory control, network analysis, simulation model, and then the dummy topic. Then the number of days we have Monday, Tuesday, Wednesday, Thursday, Friday. So here we have is 25, 20, 30, 15 and 5, 20, 15, 10, 15, 10, 30, 20, 15, 10, 5, 10, 15, 10, 15, 15. And then we see that for the dummy, it's always 0. Now let's continue with the process. And assignment, we say that you take the minimum across the first table. It's also known as the row minimization. So the minimum you have is what? 0. The minimum you have is 0, 0, 0, 0. Are we together? So how do you develop the second table? You see that to get the second table, you'll be taking all these. For example, the first one, you take 25 minus 0, you get what? 20 minus 0, 20, that minus 0, like that. So that means the second table will not change. So you can also call it the second table. That means the first table and the second table are the same. Then from the second table, you take the minimum across now the columns. And the minimum you have is what? We have 5. We have 10. We have 5. We have 10 and we have 0. Then from the second table, we go to the third table. Let's go to the third table. So you take 25 minus 5, you get 20. 20 minus 5, you get 30 minus 5, you get 15 minus 5, you get, and 5 minus 5, you get 0. 20 minus 10, 15 minus 10, 10 minus 10, you get 0, 5, 0. That minus 5, you get 25. Yeah, that's 10. So we have 5 and we have 0. I have 0. 0, 5, 5. And then we have zeros. Then we say that cancellation start from that table and you start cancelling the row or the column with the highest number of zeros. So in this case, which has the highest number of zeros? So we have that. Here we have 1, 2, 3. So 1, 2, 1, 2, you can cancel anyhow, right? And then we have 1, 0 and cancelled. So you cancel that. So that means we have cancelled all the zeros. How many lines have we crossed? We have cancelled 4. Is it optimal? It's not optimal. For it to be optimal, we must cross 5 of them. Eh? So it's not optimal. So we say that if it's not optimal, you select the minimum uncrossed value. And in this case, the minimum uncrossed value we have is what? Yeah, the minimum uncrossed we have is 5. Good. From the third table, now we go to the fourth table. So we say that for those crossed ones, you maintain. Those crossed twice, add the minimum. Those uncrossed, you raise the minimum. So in this case, we'll be taking 20 minus 5. For those uncrossed, you deduct. Eh? And you'll get how much? 15. 15 minus 5, you get 10. 25 minus 5, you get 20. 10 minus 5, you get 5. Then 0 is crossed once, so you maintain it. So then in this column, that is crossed once, we maintain. So we'll be having 10, 5, 0, 5. But this 0 is crossed twice. So therefore, if crossed twice, you add the minimum. So it will be 0 plus 5 and you get 5. For those crossed ones, you deduct the minimum. So it will be 25 minus 5. Have 20. 15 minus 5. Have 10. 10 minus 5, you get 5. 5 minus 5, you get 0. Then 0 is crossed once, you maintain. So 0, 5, 0, 5. This is crossed twice. 5 plus 5, you get 10. Zero, 0, 0, 0. So now let's continue the process of cancelling. You start cancelling the row or the column with the highest number of zeros. In this case, we have 4. So you cancel that. Followed by, here we have 2, 1, 2. You can cancel that. Also, you have 1, 2. You can cancel that. Then we have 1, 1. So you can cancel that. Here we have 1. You can cancel anyhow, yeah? How many lines have we drawn? 5. Is it optimal now? Yes, it's optimal. So here we had Monday, Tuesday, Wednesday, Thursday, Friday. Decision theory, inventory controls, network analysis, simulation, and dummy. So now let's do the allocation or the assignment. Monday, Tuesday, Wednesday, Thursday, Friday. So you see that how do we allocate? Now between Monday, Tuesday, Wednesday, Thursday, and Friday, which one has a unique 0? Unique 0, that means only 1. For example, in Tuesday, the only 0 you have is for the dummy. So Tuesday, you give the student a break. Tuesday, dummy. And once we have allocated someone to dummy, no one else should go to dummy. So that means any 0 across the dummy will be crossed. So for example, Monday had 2 options. Simulation or dummy, but we have already allocated someone to dummy. So the only option remaining is to do what? Simulation. So that means on Monday we do simulation. That means also, let's go on Thursday. Thursday, we have two options. It's either you do the network analysis or dummy, but you have already allocated someone to dummy. So the only option remaining is to do what? Network analysis. On Thursday, we do network analysis. Once we do the network analysis, no one else should do network analysis in any other day. So on Friday, we had two options. It's either you do decision theory or network analysis. But already network analysis is already undertaken. So that means the only option remaining is what? To do decision theory. Then we are remaining with Wednesday. Wednesday, you had an option of doing inventory controls, also simulation or dummy. Dummy is already taken over, simulation the same. So we're remaining with what? Inventory control. Inventory control. So that was the optimal assignment. Then number two of the question. The total number of students who will miss at least one of the seminars between Monday, Tuesday, Wednesday, Thursday, and Friday. We want the total number. So Monday simulation. So let's be here. Let's go to the first table. Monday simulation. How many students are we expected to miss? There were 10. Tuesday, 0. It was a dummy. Wednesday is inventory. At inventory control, how many students are expected to be late or to be absent? 10. Thursday, we are doing network analysis. Thursday, a network analysis, we expected how many students to be absent? 10. And lastly, on Friday, decision theory. Friday, decision theory, we expected only 5. So the total number of students who expected to be absent will be 35. Good. Can take a screenshot of that. November 2020. November 2020, question 4B. Question 4B. November 2020, question 4B, and you're told that a training institution has 4 lecturers represented by lecturer 1, 2, 3, and 4. The head of department wishes to assign them to handle 3 topics in quantitative analysis, topic 1, topic 2, and topic 3. So you have 4 lecturers against 3 topics. So that means the assignment model is not balanced. So you'll have to add a dummy teacher. This will be done based on the competence, which is measured in terms of mastery of the subject matter and personal preference on the time schedule, while satisfying policies and provision of the institutions. All the lecturers have taught the topic in the past and have been evaluated with the following scores in the 3 different topics as follows. So we have lecturers 1 to 4, and then the topics. So require the optimal assignment for the 3 topics. So we'll have topic 1, topic 2, topic 3, and then we have to add a dummy what? A dummy topic. Then we have 4 lecturers, lecturer 1, lecturer 2, lecturer 3, and lecturer 4. So that the problem should balance. So here we have 42, 48, 50, 58. Then we have 16, 40, 18, 38, 27, 25, 36, 16. Say that it's always a zero. So from there, what's the next step? We call that the first table. So from the first table, you take what? The minimum. Are we together? If you take the minimum, you have what? 0. That means the same. Will the second table change? No. Now that's how we could have failed. Actually, to be honest, this question, a lot of students failed, but they did thinking they were doing the correct thing. The correct thing. This is not a case of minimization. Can you read the question again? Now, what are those? 42, 16, 27. What are those payoff given there? Yeah, a lot of questions thought they got this question correct, but the question was a lot of students failed actually, almost 95%. They failed because they could not interpret the question. First of all, they never understood the question. Now, let me read you the point to tell you that it's a maximization case. In this case, we have 3 topics in QA, and we have 4 lecturers. We want to assign those topics. Now, what we did, we took the lecturer's prefix. Can we do that again? Let's go to the second line where you have T1, T2, and T3. This will be done based on the competency. Are we there? Competency, which is measured in terms of mastery of the subject matter and personal preference on the time schedule, while satisfying policies and the provision of the institution. All the lecturers have taught the topics of, in the past and have been evaluated with the following scores. So they were given the scores. For example, lecturer 1 in topic 1 akona score ngapi? 42. Topic 2, 16. So in this case, you only allocate to the lecturers with the highest what? So in that case, that means it's a case of maximization. We take the one with the highest score. So if you're taking the one with the highest score, so that means the problem is to maximize on the scores. And if it's to maximize, that means we have to modify that. Yeah. Can you try to do it like this? You will not get the solution. Is that true? Yeah, that's what he did. And he never got any solution. So you have to modify. And how do we modify? Remember, we said that one of the assumptions of the assignment and transport. I'm repeating this for the 4th time, that they are both founded on the ground of equality. We have satisfied that by making it balance. Then we say that they initially formulated to deal with minimization cases, but can be modified to deal with maximization case. So this one is a maximization case. So we need to modify. And you modify by coming up with a what? Opportunity loss or opportunity loss matrix. And in this case, opportunity loss matrix becomes our first table. And how do we modify that? We say that you take the highest score. Give me the highest score. Who are the highest? Is it not 16? So let's come up with the first table. So we'll be taking 60, you deduct all the other. Are you together? You just get the deviation. 60 minus 42, you get? 60 minus 48, you get what? 60 minus 50, you get? And here you get what? 60 minus 16? Is that 44? 60 minus 40, you get? 60 minus 18? Is that 32 or 42? 60 minus 38? Is that 22? 60 minus 27? Is that 33? 60 minus 25? Is that 35? 60 minus 36? 24. 60 minus 6? 0. 60 minus 0? Good. So that's the first table. Now from the first table, now you take the minimum across the row. So the minimum we have here is 18. Here we have is 12. Here we have is 10. And the minimum here we have is 0. Now from the first table, we go to the second table. So in our second table, we'll be taking 18 minus 18, you get 0. 44 minus 18, is that 26? 26, eh? Then that 3 minus 18, that's 15. And then 60 minus 18, you get 42, right? 12 minus 12, 0, 8. You have 23, and 60 minus 12, you get 48. 48. 10 minus 10, 0. 42 minus 10, you get that 2. 14, and you get 50. 2 minus 0, 2, 22, 0, and 60. Then from the second table, you take the minimum across now the columns. So the minimum you have is what? 0. Now we have 8, 0, and we have 42. From the second table, now we go to the third table. How do we develop the third table? 0 minus 0, 26 minus 8, is that 18? 18. 8 minus 8, you get 0. That 2 minus 8, you get 24. Then 22 minus 8, you get, this is 14. 15 minus 0, you get. Then 42 minus 42, you get 0, 6, 8, 18. Then we say that cancellation starts from the third table and start cancelling the row of the column with the highest number of zeros. Which one has the highest number of zeros? Yeah, we have 3. The rest has 1, 1, 1. So you have that, you have that, you have that. Is it optimal? Yeah, we have done 4 lines and we have 4 strategies. So in that case, this was lecture 1, lecture 2, lecture 3, lecture 4. Then topic 1, topic 2, topic 3, and topic 4. So how will be our assignment? Our assignment, lecture 1, lecture 2, lecture 3, lecture 4. Lecture 1, 2, 3, 4. Who has a unique 0? You have lecture 4. Are you together? Lecture 4 has only option of doing topic 3. Are you together? So lecture 3 will do topic 3. Also, you have lecture 2. Sorry, that was lecture 4. Eh? So lecture 4 is the one taking topic 3. Also, you have lecture 3. Lecture 3 has only one option to do topic 1. Once it does the topic 1, lecture 2 had 2 options. I can do topic 1, I can also do topic 2, but I have already assigned topic 1 to another lecturer. So the only option I have is to do what? Do topic 2. Lecture 1 can do topic 1 or a dummy. But you have already allocated someone to the to topic 1. So wanabakia na nani? Yeah, he will do a dummy topic. That means lecture 1 will not be allocated any of the topics. Good. So now let's go to the required. Have we answered the question? Required number 1 is the optimal assignment of the 3 topics. We have done that. That lecturer 2 to teach topic 2, lecturer 3 to teach topic 3, lecturer 4 to teach topic 3, and lecturer 3 to topic 1. Then number 2 is the maximum score. Even the question has given you a tip. The maximum score. It was not asking the minimum score. So how do we get the maximum score? So maximum score. Lecture 1 to dummy. The score is 0, right? Lecturer 2, topic 2. In this case, you use the profit or the percentage schedule from the original pay of matrix in that case. So lecturer 1, we are lecturer 2, topic 2. Lecturer 2, topic 2 was getting a score of how much? 40. Then lecturer 3, topic 1. Lecturer 3, topic 1, a score of 50. Then lecturer 4, topic 3. Lecturer 3, topic 3 has a score of how much? 60. And you get 150 per. Then number 3, the lecturer will not be assigned any of the topic. Yeah, that's lecturer who? Yeah, lecturer 1. So that marks the end of that topic. Good.